So let us talk about boundary fill algorithm. What happens in boundary fill algorithm? You have a polynomial, right? So you know that polynomial can be represented in terms of sequence of coordinates, right? So these coordinates, suppose they have been plotted here. Okay. Now what boundary fill algorithm says, we will have the boundary. These lines are already drawn. These lines should have a different color. Okay, and let us now choose another color to fill inside the boundary. Okay, so now how do we do that? We find any one of the coordinate which is inside the boundary. Then what we do? Now we actually, starting from this coordinate, suppose this is xy, starting from this coordinate, what we do? We try to find out its neighborhood. Okay, let me write it here. Neighborhood, it is NEI. Okay, so this neighborhood can be 4 connected or 8 connected. Okay, 4 connected or 8 connected, which means whether a coordinate this, if at all it is 4 connected, that means it is connected to its neighboring 4 pixels. Okay, if at all it is 8 connected, then this pixel is connected to all the 8 pixels around it. Okay, so now starting from this particular pixel, what happens in boundary fill? That you will definitely fill it. Either it will be 4 connected or 8 connected. Let us consider if at all it is 4 connected. Then for this position you will have these 4 pixels. You will put all these 4 pixels in a stack. Okay, and then you will pick one of them and check whether it is boundary or not, and if at all it is not on a boundary, then you can plot it. You can plot it with this particular chosen color. Similarly you will do, and similarly you will do for the others as well. Okay, so this is how you, and accordingly you will keep on getting, if you have plotted this new pixel, so now you have other pixels as well, right? So leaving the pixel which has already been done, these 3 new pixels can be entered here and they can be plotted, and so on, all the pixels will be plotted. Okay, so this is how we do in boundary fill algorithm. Okay, definitely this was a story of 4 connected. If at all it was 8 connected, what will happen? You can understand, it will move 8 new pixels every time. This is what you do, right? Okay, so here you have to understand that the procedure is recursive. So recursively you are calling this procedure. If at all the pixel which is either a boundary pixel or which has already been filled pixel, then you are not considering that pixel. That branch of your recursive procedure ends there. However, if at all it is a new pixel, it is kept in the stack and iterated again. right? So in this way you can fill it. One important example was where it was something like this, where you have a pixel here. If at all it was 4 pixel algorithm and 4 connected method you are using, in that case the 4 new neighbor for this will be this, this, and this. One, 2 of them are boundary and others will be okay, they will be printed and this may be filled. However, you may not get a way to fill this part, right? Yeah, if at all it was 8 connected, then it was possible. For this position you will get all the 8 points. Some of them was boundary, but one of them came in this region. This will be plotted, and after that, because of this, all the other pixels will be plotted, right? So that may be sometimes an advantage of 8 connected. However, other methods can also be there depending on your choice. Some of times you can also go for keeping 1 pixel from one scan line. Giving this 1 pixel from one scan line can also give you connected new things, new pixels to be plotted. This can be one of the procedure. So these are the these are the ways you can go through for this boundary fill algorithm. Okay. Having known about this, I believe now we can talk about flood fill algorithm. Flood fill algorithm. Okay. Let me tell you about flood fill algorithm here. Now this flood fill algorithm is a little bit similar to this boundary fill algorithm. How is it similar? Let me show you. Here also you will use this recursive procedure to fill. You will definitely use 4 connected or 8 connected ways to fill. However, as earlier you were checking for your neighbors that whether it is on boundary or not, whether this current pixel is boundary pixel or not, you need not change it. You need not check it. What you have to check it, here suppose this is the case, this is your polynomial, you have to fill this part. So usually it can be filling or recoloring, you can call it. Okay, you have to see what color it is of the interior, right? Definitely on the boundary they will have a different color. Now these color may not be same for all. See, it can be like this, it may be like this. Okay, so on the different boundary they have different color. However, interior is having a different color. Okay, so interior is having a different color, and this color whatever it is, now you don't have to check whether it is a boundary color or not. You have just to check that whether the given pixel is of your particular interior color or not, right? If at all it is of interior color, then what you have to do, you have to replace it with a new color, and you have to consider whether it is 8 connected or 4 connected. You have to consider the connected neighbors, and you have to apply the same recursive procedure on your connected neighbors. Here also you use 4 connected or 8 connected, right? So in this way you apply your flood fill algorithm. Let me repeat what you did in boundary fill algorithm is You started with one internal pixel, and with this internal pixel you plotted it with the new color, and you consider its neighbors. The neighbors can be 4 neighbor or 8 neighbors. You used all these 4 neighbors or 8 neighbors and applied the procedure on each of them. This procedure will first of all check whether it is a boundary or not. If at all it is a boundary, it will stop there, and if at all it is not a boundary, then it will apply the new color and consider its new neighbors. Okay. On these new neighbors, again you will apply the same procedure. If at all it is a boundary pixel or it is a already filled pixel, then it will stop, and again it will consider the new pixels. Okay. So this happens in boundary fill. However, in flood fill what happens? We do not check for the boundary, we check only for the internal color, its own color. We compare that whether it is the given color or not. If at all it is given color, we will replace this color and consider the new pixels around it, the neighboring pixels. The neighboring pixel, if at all it is not of the given color, in that case you will stop. If at all it was of a given color, given interior color, then you will replace it. That is what we do in flood fill. Very simple. Okay. So this is what we have seen about boundary fill algorithm and flood fill algorithm. Okay. Thank you.